Thank you so much. Warmly welcome everyone for my presentation today. Before we dive into presentation, I would like to thanks to giving me this great opportunity to present my PhD research. I will quickly introduce myself. My name is Nalinda Dissanayake. I'm from Australia. I did my bachelor's in material science and engineering. Then I did my MBA after 5 years in industry. So I decided to do the Master of Engineering Management and Additive Manufacturing. And then I decided to do a PhD. So here I am. So I'm going to present some of my results of my PhD. So today I'm going to talk which 3D printed material best represent the skull and is it safe to drill. The motivation coming for this research is actually I have got an opportunity to work with the neurosurgical department in Royal Brisbane Women's Hospital in Brisbane. So as you know that neurosurgery is a specialist discipline which requires the high level of skills, rigorous training, and all sort of different kind of trainings for get an expert with so become a consultant neurosurgeon. And how junior neurosurgeons practice this getting training for neurosurgery, as we know that. So traditional approach is C1, do1, and teach1 method, and also the being with expertise. And also the use in the cadavers. So the limitation of the cadavers, as we know that it's really high cost to maintenance for the cadavers, and also the ethical issue, and the availability is also the problem nowadays. So, and also using surgical video review for this kind of training and education. So this picture is this figure I have recently taken one of conference in Brisbane. This is the issue with this kind of models currently available in the market is low realism and low quality. And it even doesn't represent the actual thickness of the skull. And especially when we're doing something like a neurosurgical training, it gives a very offensive smell for the users. And what my research is, I'm focusing to sort out all this issue and give us something like a realistic 3D printed surgical training model for the users. All right, so let's move into what kind of neurosurgical procedures related to the human skull. There are mainly two surgical procedures, like burr hole drilling and also the craniotomy. So what is this burr hole drilling? So burr hole drilling is a small drill through the skull to get the access to the brain. And especially if you see this in video, that this is a traumatic brain injury patient. So if you can see that in the video, that they're just doing a couple of burr hole drillings to get access to the brain. So the issue is it having a more area of the brain has to give the access to the neurosurgeons. They will decide whether they need one single particular burr hole or the couple of burr holes to get more area. So that's what we call the craniotomy. Craniotomy is the getting something like a more area to get access to the brain. So that's where the neurosurgeons perform. They will decide whether they need the patient need actually single burr hole or the couple of burr hole, and they will decide whether going for the further neurosurgical treatment. Okay. So let's move into the existing literature. So what I have noticed in the existing literature is 1/3 of study, they just all focus on this craniotomy and burr hole surgical procedure. So the limitation of this current literature is actually everyone is referred like something is better than nothing attitude. So I have taken a couple of examples to show you. This is one of the model ABS material they're using, and also they're just putting a couple of layers to represent, and doesn't represent the actual skull of head anatomy. And also there's another one, they're using the material jetting 3D printing techniques. And also, again, it's a single case material, single case study using single material. All right, so limitation of the previous study, so most of the material used, again, it's like a toxic, like ABS is a toxic material, and some of materials are too soft, brittle, and because we know that when we're doing the burr hole drilling, it's using something like 75,000 RPM. So when we're drilling, so most of this 3D printed material is melting. So that's the main issue which I have noticed during this study. So again, these materials are less suitable for the realistic feeling, and also some other limitation like particular complex structure and limitation of the respect to the surgical tools. All right. So the main objective was my study is finding the best 3D printing material and 3D printing techniques to make it suitable for the neurosurgical training. So, of course, it has to be cost effective, and also it has to be safe for the users. All right, what is my experimental method? I initially worked with a couple of neurosurgeons in Brisbane, RBWH. So we started with the simple design, and neurosurgeon performed like a simple drilling and got a lot of feedback for the heaps of materials. And finally, I ended up with this design. And I used the CT scan, my CT scan file to design this head model, and also topology optimization technique to use this model. And this is the one of neurosurgeon performed the final model, testing of this 3D printed material. All right. So what 3D printing techniques and material I used for this study? I used the high-cost, currently available high-cost 2 industrial 3D printers, especially for Stratasys material jetting printer. We use the digital anomized skull and material jetting bone. And also we use the PA12 glass fill and PA12. And also we use the low-cost desktop 3D printers like FDM and SLA, white resin and 3 material using the FDM, tough PLA, FibreTuff, and also the PETG. All right, this is my study setup. We use the 2 head model for this study, and also we use the Medtronic drilling system. That is the system exactly using in the hospital. So I need to make sure that all this something similar to neurosurgical training process. So we use the extracts for the safety of the users. And you can see that 8 different skull pieces we can insert into the head model and use the insert and also the screws and attach to the head model and do the drilling. So 5 consultant neurosurgeons participate for this study. And also we use the initial survey questionnaire and survey after the drilling of each sample, and semi-structures interview question after the drilling of each material. All right, this is the video footage we have taken while neurosurgeon drilling of this 3D printed material. You can clearly see that some of the particles taking off while they're drilling. So, and that's one of the reasons we have to do the another study to make sure that these are safe for the users. All right, let's quickly move into the results. And we used the 4-point Likert scale survey questionnaire for the study. Okay, this is the summary of the results. So if you see this x-axis, there are 8 different materials for the 5 survey questionnaire. Mainly we asked to give the feedback for how the haptic qualities of the mechanical, visual appearance, interior and exterior feedback of this 3D printed material compared to the actual human skull based on the experience of these 5 consultant neurosurgeons. So they have given their feedback with the y-axis. If you can see the y-axis, the positive axis give the positive feedback. Basically, strongly agree and agree. When you move into the y-axis, negative axis, it gives the negative feedback like a disagree and strongly disagree. So for an example, if you can see that PETG PETG received the most positive feedback from all these neurosurgeons. And when you move into the x-axis, the tPLA, they got the tPLA got the worst negative feedback based on these all 5 survey questionnaire. All right, so this is the final ranking of these 8 different models. So you can clearly see that PETG and white resin, they got the highest rank for this out of 8 material, and all bone and skull material, J750, and also the PA12, PA Glassfield, they got the lower ranking for replicate the skull. All right. Also, I did the multivariate regression analysis. So why I did, so I need to find out based on the 4 different factors, which one is the most significant impact for the overall feeling. So we have found that exterior and the interior feedback was the highly significantly impact for the overall feeling. All right. You can see clearly that how after the drilling of each material, so tPLA, FibreTuff, and glass film nylon material, those are all materials are melted. And all other material like white resin, PETG, those are perfectly fine for the burr hole drilling. All right. Quickly give a summary of the study. PETG, white resin, give the high ranking for the replicate in the human skull. And also the low-cost desktop 3D printers perform really well compared to the high-cost industrial 3D printers for this study. And also the interior and exterior factors have the significantly static for the burr hole simulation of the human skull. And also the FDM printed PETG for the interior and SLA white printed one for the exterior feeling give the for the study. And if you're interested to read further detail of this study, you can go into this is already published in World Neurosurgery of my study. You can go in through this paper. All right, what's next? As I said, that it's really important to make sure these materials are safe for our valuable neurosurgeons. So because of that, I already did the safety analysis of these materials. As I said, that the objective is make sure the safety of the materials. So 1 neurosurgeon participate for this study. So I chosen the best 3 material based on my first study. We measure the volatile organic compounds and also the total particulate for the measurement of the safety. All right, as you know that the total particulate is the solid and liquid particle suspended in the air for make sure for the breath. And a lot of issues with the exposure to the total particulate and VOCs. As you know that heaps of human health issues like irritation of your nose or throat or eyes, and also the headache. And according to the standards, so the coarse particle is the aerodynamic diameter between 2.5 to 10 micrometer. We call it like a PM10, and the fine particles is a PM2.5. And according to the World Health Organization, so they have given the PM2.5 has to be less than 50 microgram per cubic meter, and also the PM10 has to be less than 45 microgram per cubic meter. Let's move into the results of this study. So based on the results of this study, PETG doesn't have any issue with the total particulate. However, the white resin and also the bone material, PM10 above the recommendation limit. So you can see that after the drilling of 10 minutes of white resin and also the bone material from the material statistic J750, how the particles taken off. Luckily, we have not found any volatile organic compound of all these 3 materials. As a summary, so PETG doesn't give any total particulate or the VOCs. And however, if you're using like a white resin or the material J750, you have to make sure that using the PPE and also the other engineering control likes, make sure that users has to be safe. All right, what's next? So the most interesting of this study is we actually used this model for training of the regional neurotrauma workshop for training of the general surgeon and theatre staff. Why in regional hospital? Because we know that every hospital doesn't have the neurosurgeons, especially like Australia, so we don't have every hospital neurosurgeon. So we train general surgeon and all theatre staff using this 3D printed model and make sure that they go to training, and in case something like coming like a traumatic head injury, they can get the initial treatment for the patient and they can transfer the patient to the hospital having neurosurgeons. So we started with, this is really interesting. We used the my 3D printed model for training of the general surgeons. You can see 5 hips of head model we're using, and also the PETG material we use for the training session. And 5 consultant neurosurgeons train all general surgeon and also the theatre staff. I will quickly give you the summary of the results. So we got around 96%, 25 out of 26 participants really recommend this model for their colleagues. And also around 80% of participants recommend and they build up their confidence to do the borehole drilling for using this head model. This is really good, right? So 3D printing makes really impact for the saving hips of life in future. And also we just planning to develop this model and implement every hospital in regional hospital in Australia, given this model, and make it training everyone using this 3D printed model. All right, what's next? So as I said, that best 3D printed model I'm using, I already proved that in qualitatively, but we need to make sure that in quantitative way, like engineering application. So I use the standard compression and hardness test using best 3D printed model based on my first study. So again, also I'm going to test with the compression and hardness test of the parietal region of the actual skull. And then I'm going to compare this 3D printed versus actual skull. And also I'm going to use the CT scan of the head and 3D printed with the after filtering of the best 3D printed settings and the materials. And then I'm going to do the instrument drilling solution to make comparable of the best 3D printed setting and the material. And I'm going to do the very soon, maybe early next year, the final simulation, final survey with the neurosurgeons. Based on maybe I have to go like a combination of the 2 different 3D printing, like a multi-material, multi-method technology. That's how the industrial happening in the next stage. As a conclusion of my presentation today, so we know that the low-cost desktop 3D printers perform really well for replicating the human skull. And also, we have make sure that how much safety of this 3D printed material for the users, especially if you're using like a white resin or bone material, you have to make sure that where the PP and all other engineering control to make sure that safety of the neurosurgeons, especially junior neurosurgeon or whoever is practicing of neurosurgical training like a burr hole or craniotomy. And also, we completed the successfully neurotrauma workshop, and we got the really good positive feedback from the participant. And that's all for today. And I would really, thanks to my all supervisors and consultant neurosurgeons in Brisbane, Royal Brisbane Women's Hospital. And also I want to thanks to Hurston Biofabrication Institute, which is one of the biggest 3D printing facilities having, and all the manufacturing facilities having, and doing all medical research in, especially in Queensland. And also, if you're interested about this area, so you can follow me in LinkedIn and upcoming papers. And if you have anyone including in your material or any kind of good positive, something like a feedback, so you can send me an email. Also, I know there are heaps of suppliers in the material, so you can send me an email, and you can include your materials to my study. So this is going to be definitely going to be an industrial application in near soon, especially in Australia. So we already started to apply this 3D printed model for the actual, real, practical life application for the, especially in the medical industry. And I want to thank everyone for listening. Thank you so much for giving this opportunity. Thank you. If you have any question, please ask me. I don't know whether I have enough time or not.
Maybe one quick question.
Yeah.
You have come a long way.
Yeah.
And there was a lot of information there to fit into 20 minutes. So just a reminder, you can see the presentations again online. The cameras are up there recording. They will be rendered overnight and be available online soon. Nalinda, thank you very much. If you have a question now, raise your hand. I'll bring you the microphone. If not, you can mob Nalinda. How long are you here for?
Sorry?
How long are you staying for?
Just only for this day.
Just for one day only.
Sorry, my sound was really bad. I got sick yesterday, and I got emergency medical yesterday. And I try to come here today and just try to make this happen.
Thank you very much.
Thank you.
Thank you.
Thank you so much.